This video is designed to demonstrate how to compute power and minimum sample size for the root mean square error of approximation that is calculated when fitting a structural equation model. And in order to calculate power and minimum sample size, we're going to use the calculator developed by Christopher Preacher and Donna Kaufman. Now, prior to using this calculator, it's important that you install R. And you want to install R, of course, for the appropriate operating system that you have on your computer. So you see there's Windows versions and then there's a Mac version. And one hint about the Mac version is there's also an accompanying program that you need to install. It's called Quartz in order for the R program to work on the Mac OS system. So going back to this calculator, what I'm going to do is use the example that we have already run that was presented in Chapter 10 from A Beginner's Guide to Structural Equation Modeling by Shoemaker and Lomax. And we can see in this model, looking at the relationship between academic performance and job performance, that when we run that model in Stata, the degrees of freedom are 3. The RMSEA is 0.00, which indicates a perfect fit, and the sample size is 500. But what we don't know is the power. Although it's a good model fit, we don't know the power of that fit. And so by using this calculator, we can determine the power. So if we scroll down, we can start by filling in our alpha, and we usually like our alpha level to be 0.05, and of course it can be 0.01 or 0.001, however rigorous you want your type 1 error rate to be. And then our degrees of freedom was 3, and there were 500 in the sample that we used to run the model. So for our null hypothesis RMSEA, we're going to put in 0.00. And we like this because this is saying that we want to accept the null hypothesis that there's no difference between our sample covariance matrix and our implied covariance matrix. And then our alternative hypothesis, if we reject this, then we'll make this at 0.08, which is really at the threshold of a acceptable fit. And so that will be our alternative hypothesis. So if we reject this, then we're accepting this, that we have poor model fit. So in order for me to get the R code to run this analysis, I just simply click on generate the R code. Now I don't have to do anything with it, but if you have R installed, then when you submit to R, you'll see that my power is 0.74, okay? But what we like is our power to be at least 0.80. So we also can come down here and we can compute what sample size we would need to obtain a power of 0.80. So we can put 0.05 here, and we have 3 degrees of freedom. Our desired power is 0.80, and again, our null hypothesis will be that there is no difference between the sample covariance matrix and the implied or the estimated covariance matrix. And then our alternative hypothesis will be poor model, well, just on the cusp of being considered a poor model fit. We usually say 0.08 is acceptable. So we can generate that R code, and then we could submit it to the web. And what this tells us that we should have or would need 568 individuals in the sample to be able to obtain a power of 0.80 and to be able to have an RMSEA of 0.00. So we know from our example that we had 500. So if we were planning this analysis and we had calculated the degrees of freedom that we were going to have based on our model, based on this model that we've developed, and we were hoping to get an RMSEA of 0.00, that's what we were attempting to get, then this sample size would not be adequate. We would need at least 568.